Welcome to this platform. So in this video, let us have a look at atomic structure. So now, before we even start, let me mention that the information that we are going to discuss here is just a basic information about the atomic structure. If you are doing a chemistry at an advanced level or university entry level, this information might not be enough, but enough to give you a start. All right, so let us start by defining what an atom is. So if you're asked to define an atom, and this is a viable question, if you are doing chemistry at secondary level, you might find a question asking you to define an atom. Now, how do you define an atom? So to define an atom, you are going to write, or this is how you define an atom, is as the smallest particle of an element that take part in a chemical reaction. So that is what you call an atom, or you can define it also as the smallest particle of an element that can never be, or that cannot be further subdivided by any chemical means. Okay, so that is what we call an atom. Now, here we are saying it's the smallest particle of an element, so we can say even if an atom is the smallest particle of an element, it even has some particles inside it. And these are what we are going to call subatomic particles. So these are particles that are found inside the smallest particle of an element called an atom. And they are called subatomic particles. What are subatomic particles that we can look at? So one, protons, neutrons, and electrons. So these are found in an atom, or they make up what we call an atom. All right, so let us look at now where these are found in an atom. Okay, let us look at where they are found, or how they are positioned in an atom. So like I said, this is just to give you the basic information or a start in chemistry. Okay, but enough for the exams if you are doing secondary education or you are doing a high school level. So this is the detailed structure of an atom. Now let us label this diagram. So what you are seeing here, since we are saying the subatomic particles, there are three of them, and this whole is an atom. Okay, the whole of this is an atom, the structure. Now, how are they positioned in this atom? So these are X that you are able to see. These are called electrons. Okay, so it's very important. These are called electrons. But also let me mention that electrons can also represented using dots. Okay, so you can use dot, or should we call these cross? Yes. So dot and cross can be used to represent an electron. And they are found in the series of circles, and these are what we call shells. So electrons are found in the shells, or energy levels. Okay, energy levels. So the other name for the shell or shells are also called energy levels. So we have different shells here, and they are labeled from K up to, or going up. Okay, so which means the first shell is K, the second one is L, the third one is M, and so on and so forth. But at the moment, it's very important that you know that electrons are found around the shell. Then you have the center of this atom, and that is what we call the nucleus. So the center is called the nucleus. Now, in the nucleus, that is where you find the protons. I'll use P for protons, and neutrons. So the nucleus simply is made up of protons and neutrons. Okay, and we are going to look at now the other part that we can look at just right here in terms of the charges. So the protons are positive. Okay, let me just write it. The protons are positively charged. So in terms of charge, the protons are positive. Then in terms of charge, the neutrons, as the name suggests, they are neutral, which means they have a charge of 0. Then for the electrons are negative. Okay, so electrons are negative. So they are negative. So that is something that you should know. Now, another thing that you should know about these is in terms of masses or the mass. So protons are measured in what we call atomic mass unit. So in terms of mass, protons have 1 atomic mass unit. That is their weight. Then for neutrons, also 1 atomic mass unit. But for electrons, is almost 0. So we can say their mass, you can approximate it to be 1840 atomic mass unit. So compared to protons and neutrons, more like they do not even count. Their mass do not even count. About 2,000 times less than that of protons and neutrons. I guess you get that. Okay, so that's the basic information that you need to understand about this. So please, the units are atomic mass unit. Okay, so take note of that. All right, so what have we discussed? So far, we've looked at where these are found. So the protons, we are saying they are found in the nucleus, and the neutrons. So neutrons and protons make up the nucleus, as you can see here. Then overall, the nucleus is positive because the neutrons do not have a charge and the protons have a charge of positive. So overall charge of the nucleus is positive. Then electrons are negative. So it is the negative charge of the electrons and the positive charge of the nucleus that holds or that keeps on the electrons moving around, that holds the electrons around what we call shells. Let us have a look at the terms that we are going to encounter as we study an atom. So some of the terms that we are going to, or that we need to familiarize ourselves, one is atomic number. Atomic number is also called the proton number. And it's very important that the letter that is used to denote atomic number is not A, or rather P. Instead, it is Z. So it is neither A nor P, but Z. In this case, I mean Z represent atomic number. Now, it's very important for you to know what an atomic number. In an exam, you might find a question asking you to define what an atomic number is or to calculate. To do that, you should be able to understand this part. To define an atomic number, we are going to say an atomic number is the number of protons in the nucleus of an atom. So, the nucleus that you are able to see here, which is the center, the number of protons, if we were to count them, it is what we call atomic number. Okay, so there's a key. I think I should have put a key somewhere. Well, let me just put a key here to represent these circles that are blue. I'll say they are protons, and these that are green, I'll say they are what? They are neutrons. So if we were to count from here what we have, the number of protons, we are going to say 1, 2, 3, 4, 5, 6, 7, 8. So the atomic number is 8. You might find the questions where you are given the nucleus and you are asked to count, or you are asked what is the proton number or the atomic number of an atom. You can count. Always you are given a key. So I've just given you that because I've seen such in an exam where you're asked to count, or where you are asked, you are supposed to count. Okay. Then neutrons, you can count, of course, from here. Since green represent neutrons, there are 4 of them. So atomic number is just a number of protons in the nucleus of an atom. So that is very important to understand. All right, another term that we can look at neutron number. So neutron number denoted as N, and it's just a number of neutrons in the nucleus of an atom. That is what we call neutron number. And I guess if you are given a question here, you wouldn't be able to miss it if you're asked to define what neutron number is. But most importantly, you need to understand or to know the letters that are used to denote these. Very important. The third term that we can look at is mass number. Now, mass number is also called nucleon number. Do not confuse neutrons or neutrons, however you pronounce, and nucleon. These are two different. So neutrons N, but nucleon is just the same as the mass number, and this one is denoted as letter A. Now, this is the challenge that you're going to face. Some of you think mass number is supposed to be M. No, mass number or nucleon number is denoted as the A. So very important to understand these things. Now, coming to mass number, what is mass number? How can we define mass number? And by the way, these are questions that you find in an exam, okay? Have I seen the question asking you to define nucleon number or mass number? Of course, in the recent past papers, you should be able to find these questions, all right? So, mass number is just a sum of protons and neutrons in the nucleus of an atom, okay? The sum of protons and neutrons. So, which means when you add protons and neutrons, gives you mass number. Let's take, for example, if this is the nucleus, and in it we have the protons. The protons, I'll use red, so I'll put a key here. This is for protons. Then I'll use blue for neutrons. So blue for neutrons. Okay. So if I had asked to find the mass number of this atom, you just add everything. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the mass number is what? 12. What have I done? I've added the atomic number plus neutron number, and it has given me the mass number. And therefore, the formula that we can use here, or we can come up with a formula to connect the three, and that is the atomic number Z for atomic number for Z, then N for neutron number, okay, then A for mass number. Meaning when you want to find the mass number, you are going to add the protons and the neutrons, but you should be able to go around using this formula in the case you're asked to find the atomic number given the neutrons, or given the neutrons and the mass number. Should be able to do that. Is that okay? So up to this point, I believe you've been following, okay? So if you've not followed, you might want to go through from the start once again. So you might want to go through from the start once again, and of course you should be able to catch up. All right, if there's no problem, let us proceed to look at now an example on the calculation, how we can apply this simple formula. Okay, so here is a question, and the question reads, an atom of calcium has 20 protons, so already we know that Z is equals to 20, and mass number of 40, A is equals to 40. Find its neutron number, or determine the neutron number. So just write this formula, N, Z plus N is equals to A. You replace, what is Z? 20 plus, what are we finding? Neutrons, equal to 40. So here N equal to, you can put here, we subtract or we bring this one the other side the usual way that we are used to. So this is 40 minus 20, and neutron number should be able to give us 20. This is the reason why I said you should be able to go around just using this formula. Okay, so that is how you find the neutron number. Let us say this one was given as the neutron number. Let us say this one was given as the neutron number. Then this one was given as the proton number. Okay, so the proton number. Let us say this one was given as the proton number. Okay, then which means the proton number of 20. Then they say find its mass number. Find its mass number. So here you are going to change it now. The same formula you're going to apply, but look at this. This time around you're finding mass number, which is A. So Z plus N equal to A. So you're going to put a 20 plus 20 equal to A. And this A should be able to give you 40. So that is how you find the mass number. Okay, and I hope that up to this point you have followed and you are able to get a thing. All right, let us look at another part. Okay, let us look at another part, which are isotopes. Okay, so very important also this part. You should know how to define an isotope or how to define isotopes. Okay, so what is an isotope? And this is a viable question that you find in an exam. You might be asked to define an isotope. How do you define it? So isotopes are atoms of the same element having same number of protons. Take note. Atoms of the same element having the same number of protons but different number of neutrons. You can end there. You are still going to get this one 100% correct. Or you can define it as are atoms of the same element having the same number of protons but different mass number, which means this time around you are going to ignore neutron number. Instead you put mass number. You are still 100% correct, or you can put O. So that is how you define isotopes. So you should be able to define isotopes precisely. Okay, now what are some of the examples of isotopes? Since we are saying atoms of the same element having the same proton number but different number of neutrons, and you should know that most of the elements that are found on the periodic table are isotopes. I'm sure you've seen the periodic table of which the mass numbers are not exactly. We are going to look at that exactly what I mean. So now, examples of isotopes, we have carbon. So carbon is an element, but we have carbon 12. So when you see something like this, you know that it's carbon 12. It's read as carbon 12, which means carbon with mass number of 12, carbon 13, and carbon 14. In all these are mass number. Okay, these are mass number. But their atomic number remains the same, which means they have atomic number of 6, atomic number of 6, atomic number of 6. Where am I getting these numbers? On the periodic table, carbon has atomic number of 6. Okay, but the one that you find on the periodic table, you find carbon 12 because it's the most abundant and the stable one. And that is the reason why you find carbon 12 on the periodic table. So now, some of you might be asking, okay, so these, please, the mass number, if you go on the periodic table, A, and we have down here Z. We normally have the number on top there and the number down. This is atomic number, the number on top is mass number. If we are to check carbon, it is 6. Okay, then the other example of isotopes, we can look at hydrogen. So we have hydrogen 1, hydrogen 2, and hydrogen 3. Then chlorine, there's chlorine 35 and chlorine 37. Okay, so these are some of the isotopes that we can look at. Have I said they are the only ones? No, I've said these are some of the examples. So as you study, as you go through, make sure that you look at some of other isotopes. Okay, and you should be able to explain why the mass number or the relative mass number of the elements on the periodic table are not exactly. In short, they are not whole numbers. Okay, should be able to answer that question even as you go through this part. All right, so let us advance further and look at relative atomic mass. Relative atomic mass. What is relative atomic mass? Relative atomic mass is the mass of an atom of an element compared to 1/12 mass of carbon 12. That is what we call relative atomic masses of an element. So all the elements that you find on the periodic table, like I said, an element that you find, let's say X, then on top there's A, then there's Z. This is just general. This number on top is what we call relative atomic mass. Okay, and this is the atomic number down, but we are looking at relative atomic mass. So all those are compared to 1/12 mass of carbon 12. Okay, and this is because it is the most the most abundant of the carbons. Okay, now what is more important that you need to understand as you go in an exam? You should be able to know how those relative atomic masses were calculated, or rather how to calculate the relative atomic mass. You really need to know that particular part. The question is that how do you calculate the relative atomic mass? So in order for you to calculate the relative atomic mass, you are going to use this formula. AR for relative atomic mass is equal to the relative atomic mass of A. So in this case, if it's an isotope, if there are 3 of them isotopes, normally you are given the relative atomic mass. Then you should be able to multiply it by its abundance, normally in percentage. So you're saying relative atomic mass of A multiplied by percentage abundance of A plus, okay, so this, the whole of this, divide by 100, then plus, if there are 2, relative atomic mass of B, which means the second one, multiplied by the abundance of B, which is the second one still, divide 100. So do not worry about how to use this formula, because we are going to look at an example. But this is the simple, or this is the simplest part that, this is the simplest way you can write this part. Okay, let us look at an example, maybe to help us to understand exactly what I mean. So here is a question. Chlorine has 2 isotopes. So this one, the one that start, we can put it as A according to the formula, but I'm not saying that every time you put this one. So what I'm saying is that the first one we can put it as A, then this one as B. So chlorine has 2 isotopes, that is chlorine 35 and chlorine 37, with the abundance of 75 and 25 respectively. Calculate the relative mass for chlorine. So how do we calculate the relative mass of chlorine? So now here we are going to write the formula. Relative atomic mass is equals to, what is the formula? Relative atomic mass of A multiplied by the percentage abundance, okay, abundance of A, plus, so here A is chlorine. You can put, instead of writing it this way, you can just say relative atomic mass of chlorine 37 multiplied by the percentage abundance of chlorine 35, chlorine 37, plus, this is divide 100 by the way, plus relative atomic mass, okay, relative atomic mass of chlorine 37 multiplied by percentage abundance of chlorine 37, please. So just write what I've said, then divide 100. Now here, where it comes to replacing, you are going to say relative atomic mass of chlorine 37 is, chlorine 35 is just 35, so you're going to say 35 multiplied by the abundance. They are saying here 75, so the first one goes to this one as there is respectively here. So percentage abundance, which is 75, is for chlorine 35, so multiply by 75, then plus, I should have divided here by 100, then plus percentage, that is relative atomic mass of chlorine 37 multiplied by, which is 37, multiplied by percentage abundance of 37 is 25, divide 100. So you should be able to multiply 35 multiplied by 75, then divide 100 plus 37 multiplied 25, divide 100. What are you able to find? Okay, so this one is 35 multiplied by 75 divide 100 is 26.25, if I'm not mistaken, plus here it is 9, is it 9.25? Yes, 9.25. And when you add these, you should be able to get 35.5. And this is the reason why scroll in on the periodic table, you're going to find 35.5, then 17. Okay, so this is the answer that we find. And these questions are, you might find the questions in an exam such as this. So please, it might not be exactly the presentation or how the question is phrased, but at least you should be able to go around calculating the relative atomic masses. I guess there's no problem up to this particular point. All right, aside from aside from isotopes, the other part that you should be able to know, you should be able to know how to write electron configurations and also structures. So let us look at electron configurations and structure. So what is an electron configuration? An electron configuration, writing an electron configuration, you are just showing the arrangements of electrons in the shells of atom or in the shells of an atom. So electronic configuration, we are just looking at arrangement of electrons in the shells of an atom. That is what we call electronic configuration. Okay, so now it is very important to know the rules that applies when it comes to electronic configuration. You don't just assign electrons. Okay, since we are saying it's just the arrangement of electrons in the shells of an atom, and there are rules that you follow in assigning electrons. So one thing that you should know, that the formula that you can use to assign electrons is this one. Okay, that is 2n to the power 2, where n is the number of shells. So the number of shell that you are dealing with, that is n. For example, in the first shell, if we were to apply this formula, in the first shell, that is shell number 1, so n is 1 square. So I deal with this part first. 1 square is 1. 1 multiplied by 2 multiplied by 1 is just give you a 2. So in the first shell, you should have only the maximum number of 2 electrons and not beyond that. So as you are assigning electrons, you make sure that in the first shell you have 2 electrons. Okay, then in the second one, the shell number is 2, so 2 square is 4. 4 multiplied by 2, it is going to give you 8. So in the second shell, you should put 8 electrons. Okay, then the third one, you are going to say 2, 3 square. 3 square is 9. Multiplied by 2, it is 18. So in the third shell, you should have 18 electrons. Okay, so please here, you should understand that the maximum number in the first shell is 2, and this is the shell is stable. So this is all for stability. In the second one, stability 8. This is called duplex rule. And this is called octet rule. So now, at this level, as we are doing secondary chemistry, normally you go with the octet rule. Okay, so when you reach the third shell, you're still going to add 8. The fourth shell, 8, but you should know, or you should be aware of this one. There are some of the complex atoms that you're going to, or elements that you're going to look at, that you need to apply this one. But at the moment, I can assure you that octet rule, that is 8 after the second shell, it applies. Okay, so just continue with 8, 8, 8. Okay, so I'm going to explain much here as we get as we go on. Okay, as we look at the other part, that is such as formation of ions and all that. But at the moment, you should know that in the first shell, as we assign the configuration, there should be maximum number of 2 electrons. In the second one, there should be 8. The third one, we are going to put 8, and of course, and so on and so forth. Okay. Now, to spice up on this one, or to add some fresh to this, or to what I've just explained, let us look at an example. So here is an example. Write the electronic configuration in each of the following nuclide and draw the structure. Okay, so what are those that we are going to write the configuration? So A, let us look at uh, that is lithium. Let me start with lithium. So let us look at lithium. So this I'm just getting from the periodic table. So lithium on top has 7, then here 3. Then the second one that we are going to deal with, let me say B. Let us look at the sodium. So sodium has 23, then here 11. Then the third one, that is C. Let us look at calcium. So calcium here has 40 and here has 20. Then for that is CD, let us look at choline. Choline has 35 on top, then here 17. Okay, then let us look at that is E, oxygen. Oxygen has 16 on top and 8 down here. So each of these we are going to write the configuration and draw its structure, because these are the questions that you expect, writing the configuration and also drawing the structure. So we are going to start with A. So for A, which is lithium, let us write its configuration. Okay, so to write the configuration for lithium, which is Li equal to, look at this, we normally use atomic number to assign configuration. Okay, we use the atomic number to assign the configuration. And one thing you should know is that the neutral atom, or an atom, is electrically neutral. That is something that you should know. An atom is electrically neutral, meaning the number of protons is equal to the number of electrons. And this is the reason why we are using the atomic number to assign the configuration, because in the configuration we put electrons. But where do we get electrons? The number of electrons or protons is equal to the number of electrons. So we use protons because they are equal to the electrons. I guess I've not confused someone. All right, so in the first shell, remember the rules. In the first shell, we only have 2. Then you can separate with a comma. What remains? So the first shell accommodates only 2. Whatever electrons that remains out of this one, 3, you take it to the next one. So the next one can accommodate 8, but it can also accommodate less than 8, but not more than 8. And the first shell, I should mention that, can accommodate less than 2, which is 1, but not beyond 2. Okay, I guess you get that. So the next one will take it outside. And this is the configuration of lithium. Let us put up its structure. So the structure of lithium, it is going to be like this. So we can start the center part, which is the nucleus. I'll just put Li. So you normally put the nucleus. I'll put Li to represent lithium. Then look at this. This configuration that I've put, it tells us about the number of shells that we are going to use. So in this case, the number of shells are going to be 2. Okay, this and this. So which means I'm going to put 2 circles around the nucleus. So I'll put the first shell and I'll put the second shell. Okay, now let me put electrons. Remember, electrons we can use cross or dots. Let me use dots in this one. So I'll put 2 electrons in the first shell, aligning them like that. Then in the second shell, I'm just going to put 1. So this is the structure of lithium. This is the configuration of lithium. Is that okay? So I guess up to this point is just okay. Let us look at B. B, we are dealing with sodium. So sodium, Na, the configuration of sodium, we have 11 electrons. So we are going to put the first 2 in the first shell. Out of 11, what remains? That is 11 minus 2. This gives us what? This gives us 9. So in the second one, you know that it accommodates only 8. So we're going to put 8. Out of 9 minus 8 gives us or leaves us with 1. So the third shell can accommodate 8 or 18. But if less than, or and also less than 8. Okay? So, but not 17. 18 exactly, but not less than what? 8. So which means the remaining one, we are just going to, less than 8. We are going to put it there. So this is the configuration of sodium. Now, like I said, the configuration tells us number of shells. So this is the first shell, this is the second shell, this is the third shell. So which means we are going to have 3 circles around the nucleus of sodium. So let me say this is the nucleus of sodium, Na. This is the nucleus of sodium. Then around it, I'm going to put 3 circles. The first circle, the second circle, the second circle. Make sure that your circles are spaced so that they do not become close, or just for the sake of neatness, make sure that you draw nice circles. So I'm going to use close this time. So 2 electrons in the first shell, 8 in the second one. So I'll pair them like that. If you want, you can put them 1 1, but they look nice if you pair them like that. Then in the outside, there's just 1. So this is the structure of sodium. All right, let me just try to remove some of these so that we can put up some more structures to avoid disturbing the information that is ahead. But remember, I'm going to leave you with some questions that you're going to answer. So let me just go for calcium. Okay, so calcium, Ca, that is 40 and 20. The configuration of calcium is 2. Okay, we are using this 20. What remains out of 20? 18. So we have 8. Then what remains? You are remaining with the 10. So I'm going to put another 8. Then what remains is a 2 outside. So which means calcium is going to have 1, 2, 3, 4. 4 circles around the nucleus. So calcium, Ca, around its nucleus, we are going to have 4 circles. Okay, this is the second one. This is the third one, and this is the fourth one. I guess I've put 4. Let me use crosses for electrons. So the first shell I've put 2. In the second one I've put I'll put 8. Okay, like that. You see why I said the space should be enough so that you don't put them like this. So in the third one as well, I'm going to put 8 electrons. Then outside I'm going to put 2. So this is the structure of calcium. So can you go for chlorine and also oxygen? Make sure that you draw the structure. All right, so I guess this part, there's no problem, and we can proceed to the next part. All right, so the next part that we are going to look at are now ions. And the first thing that we are going to do is to define what an ion is. Maybe this time around you find a question asking you about ions. So it's very important to be on the safe side to know how to define an ion. So to define an ion, we are going to say an ion is a charged particle. An ion is just a charged particle. Okay, and there are different types of ions. So we have the positively charged, let me not say different, but 2 types of ions. So we have the positively charged ion called cation. So cation is a positively charged ion. And we have what we call anion. Others will say anion. However you pronounce it will meet in spellings. But it is a negatively charged ion. So these are 2 types of ions that we can look at. But the question is, how are these ions formed? So now, after looking at isotopes, if I didn't mention this, you should be able to know that isotopes or atoms of, since we are saying isotopes, they are atoms of the same element, but you need to know that some isotopes are not stable. Okay, of the isotopes that we have, some are not stable, and therefore they act in a way to gain stability. So now, in order to gain stability, atoms of an element can choose to lose or gain electrons, especially those that are not stable. So they choose to lose or gain electrons, or they can lose or gain electrons. When an atom of an element loses electrons, it becomes positively charged, and therefore it is called cation. When it gains electrons, it becomes negatively charged, and it becomes a negatively charged, it becomes negatively charged, and that is what we call anions. For you to know, we said atoms are electrically neutral, which means the number of protons and electrons, if we are to add them, they will give us an overall charge of 0. Okay, that is what I said. Now, the protons do not change, but the number of electrons can increase or decrease. When it gains electrons, it increases, the number of electrons increase. When it loses electrons, the number of electrons decreases, which means you have more protons than electrons. But when it gains, you have more electrons than protons. I guess you get what I'm trying to say. Anyway, I'll get to explain much. I think I'll get to use this part more as we look at the formations of ions. All right, so let us have a look at formation of ions, since we said there are two. So we're going to start by looking at the formation of a positively charged ion. And you know that positively charged ion are ions formed by loss of electrons. And mainly, protons are more than electrons. All right, so that is about the formation of positively charged ion. And I should mention that these are ions mainly formed by metals, because metals tend to lose electrons in order for them to gain what? Or atoms of metals tend to lose electrons and in order for them to gain stability. So we can safely say that most metal loses electrons and become positively charged, which means they form the cation. Okay? Now, let us look at examples. So the first one that we are going to look at is lithium. So lithium, if we are to look at the configuration, please, we are looking at formation of positive ion. The configuration of lithium, we said, is 2, 1. Now look at this. The first shell is stable because the required number, it has made the required number, which is 2. But for the second shell, it is unstable. Why is it unstable? The required number of electrons here is 8, but it only has 1 with a shortage of 7. So therefore, this one is unstable. So lithium atoms will act in a way to gain stability for them to be stable. So long as the outermost shell here, because this one which is outside is called the outermost shell, which means the shell on the outside, it is unstable. So it will act in a way to gain stability. But what is going to happen? Okay, so in order for lithium to gain stability, let me just go down here. So the configuration of lithium is 2, 1. And we are saying this first part is stable. That is, the first shell is stable. But for the second one, it is unstable. So the atom will act in a way to gain stability. Now, what is going to happen? In the outside shell, the required number of electrons for stability is 8. There's a shortage of 7. So the atoms or the atom or lithium can gain 7 electrons to be and become what? Become stable. So in order for lithium to become stable, it can gain the 7 electrons that are missing from somewhere, or bring in the electrons that are missing from somewhere and become stable. Or it loses this 1 electron, which means the configuration of lithium is just going to be 2. And in this case, it is also stable. So any of the two ways that I've mentioned, so gaining 7 or losing 1. Now, how do you know whether it is going to lose or gain? Very important. So now, one thing that you should know, that gaining and losing of electrons requires the energy. So an atom spends much energy on gaining and losing, or when it gains or loses electrons. I guess you've gotten that point. The more electrons gained or lost, the more energy an atom is going to use. Get this one very well. Gaining and losing of electrons in an atom requires energy. The more electrons an atom gains or lose, the more energy it loses or it uses. An atom, here an atom will not want to lose more energy, so it will go for the process that requires less energy. Now, look at this. Here we said lithium, the configuration is 2, 1. It needs 7 to gain 7 or lose 1. It is very easy for lithium to lose 1 electron because it is going to use less energy than gaining 7 electrons so that it can add to this. So losing outermost electron, it is losing also the shell, but gaining 7 to add to this to make 8, it is very it requires a lot of energy, and therefore it will go for the process that requires less energy. And therefore we can say in this case lithium is going to lose an electron. And if lithium loses an electron, it is just going to remain with the 2 electrons. Now remember what I said. An atom is electrically neutral. If you add the protons and the electrons, they should give you the overall charge of 0. That is what it means. Have you gotten that? So before any reaction, an atom is electrically neutral. So even lithium has a mass number of 7, protons of 3. So before any reaction, lithium has 3 protons and 3 electrons. I've put negative for electrons. The overall charge, if you subtract it, to give us what? 0. But what happens when it loses 1 electron? The number of electrons reduces from 3 to 2. Therefore, this same part is going to be 3 minus 2 equals to, what are we going to find? 1. And this one is positive. So positive 1. Now, in terms of charges, we do not even write 1. Instead, we just put positive. And this is the reason why when lithium loses an electron, it becomes lithium positive with this positive charge. So this simply means it has lost electrons. I guess I've cleared the confusion, because some of you might be thinking, but how come if it has lost, it become positive, but when it has gained, it become negative? I guess I've helped you to understand that part. So it is because of this. So an atom is electrically neutral, which means the number of protons is equal to number of electrons. Okay, so it can be shown like this for lithium. So now what has happened here, we are saying lithium is going to lose, it is easy for lithium to lose 1 electron than to gain 7. So it is going to lose 1 electron and remain with only 1 shell. So 1 electron has gone. It is no longer electrically neutral because 1 electron has gone. So this time around is going to be 3 protons and 2 electrons. And if you are to do the mathematics here, you are going to find a positive, which is 1. So this is the reason why lithium is or has a charge of positive. So lithium ion is like this. So in formation of lithium ion, we can present it like this. So lithium, the normal one, okay? So in this case, it become lithium ion, okay? Lithium ion. So it plus 1 electron is lost. So this is how we can present it. Now, in terms of structures, we can write the structure of lithium, the normal one. Okay, how many shells? We know that is 2 shells. Okay, 2 shells for lithium. Then now, let me just put electrons here. So 2 electrons. Then also here, lithium. This time around, it become lithium ion. Okay, so it remain only with 1 shell. So with 1 shell and 2 electrons. So you put it in the brackets like this. Then on top there you put a charge. Then you add plus an electron. So this is how you present the formation of lithium ion. I can even put the configuration here, which is 2, 1, then here lithium, which is positive, which is just a 2. So something like this. Okay, which other one can we look at? The other one that we can look at is sodium. So let me just add sodium here. So sodium is Na. The configuration of sodium is 2, 8, 1. Now look at sodium. It has how many shells? 1, 2, 3. Want to look at the formation of sodium ion. So sodium in the outermost shell. So please always you just look at the outside shell, because this one is stable, this one is stable. It has the required number of electrons, but the outermost shell, it is 1. Now 1, what is the required number? The required number is 8. So shortage of 7 as well. So it is very easy for sodium to lose 1 electron than to gain 7 to make 8. So it is easy to lose 1 so that it can just remain with these stable ones than to gain 7 with what I've explained. So sodium is going to be, sodium ion is going to be 2, 8. And in this case, what will happen to number of electrons? If we want to go back, sodium before any reaction, it was electrically neutral, protons and electrons, giving you what? 0. Okay, protons are positively charged. So how many are the protons? Sodium is 11, 23. These are the protons. So 11, electrons are negative, negative 11, equal to 0. But 1 electron has been lost, so the number of electrons has reduced to 10. So 11 minus 10 equal to, still giving us 1, which is just a positive. Okay, so sodium ion is going to appear like this. In terms of structure, this is sodium. How many shells around? The normal one is 3. So I can put 3 circles around. 3 circles around. Then this one, this is sodium ion. Then how many circles remains? 2. So 2 circles around. Then I can put this one in advance in this form. So positive on top. Electrons, electrons, electrons. Okay, like this. Then this one like this. Like this. Like this. Okay, no, just have 1 on the outside, then plus electrons. So that is how you present it. The configuration of sodium is going to change to, this is positive on top, which is the charge, is going to be 2, 8. Then this one is going to be 2, 8, 1. Okay, this is sodium. All right, so that is the formation. So this is sodium ion. All right, let me just look at maybe one more for the one that has a different one, the one that is losing, let's say, more than 1 electron. So let us look at which other one did I give here on examples. Let us look at magnesium. So magnesium is Mg. Let me just clean here. So magnesium is Mg. So Mg, magnesium, which is 24 and 12. The configuration of magnesium is 2, 8, then 2. Now look at this. This shell, the first shell is stable, the second is stable, but the third one is not stable because the required number of electrons is 8 and we only have 2, a shortage of 6. So now, is it going to be gaining 6 to make 8 or losing 2? Which one is easy? It is easy to lose 2 than to gain 6. Okay, so the atom will use less energy to lose 6, to lose 2, less energy to lose 2 than to gain 6. So it is going to lose 2 electrons. And therefore magnesium ion, it is going to be, the configuration is going to be 2, 8. Now let us go to our thing. Protons plus electrons equal to or giving us 0. An atom is electrically neutral. What is the number of protons? 12. Plus the number of electrons, also 12, equals to 0. Now we are saying it is going to lose 2 electrons. So number of electrons affected, so it will be down by 2. So 12 minus 10, which is equals to, what is the answer? It's going to give us a 2. But since we are looking at charges, we put a positive at the end. So not positive 2. 2 positive, and these are 2 things different. These are integers, but this is a charge. So charge, why you put a positive at the end? Because it's a charge. Immediately you put in front, that is an integer, and that is wrong. Okay, so which means this one is going to be 2 positive, and that is the reason why Mg ion is written as such. Okay, so in terms of structure, you can put Mg, then how many circles around? The normal one, 3 circles. So 1, 2, 3. Okay, then here we can put Mg ion, 1, 2. We are just going to remain with 2 shells. So let me just put it in these brackets. Then on top there we can put 2 ion. So here 2 electrons. Then we have something like this. So it's going to be something like this. Then here 2, something like this. Something like this. Then outside we have 2. Then here we can put plus 2 electrons. So this is how it's going to appear, the ion, or this is how it is going to form. So this is magnesium, a normal one, 2, 8, 2. Then magnesium ion, which is 2, 8. Okay, I guess you followed. So can you do for aluminium? Okay, so aluminium, it is this one. The configuration of aluminium, it is 2, 8, then 3. Okay, so do for aluminium and see if it works. All right, the other part that we can look at now is the part for anion. Anion is a negatively charged ion. Okay, the negatively charged ion is what we call anion. And for it, it has, it is as a result of atoms gaining electrons in order for them to be stable. So normally non-metals gain electrons in order for them to be stable. So non-metals gain electrons, okay, in order to be stable. So in this one, which means you have more electrons than protons. When we consider an atom to be, okay, we have more protons than electrons. So let us look at formation of anions or anions. And the first one that we are going to look at is chlorine. So chlorine, as you can see, it is 17, the proton, and 35.5, the mass number. We use the proton number to assign the configuration, and therefore the configuration of chlorine is going to be 2 in the first one, 8 in the second one, then whatever remains in the last one, which is 7. Okay, then now what happened? Chlorine, before any reaction, it is electrically neutral. Protons, if you add with electrons, should be give you a charge of 0. So now, in this case, we are going to say the number of proton is 17, minus 17 is equals to 0. Now look at this. Outside shell has 7, and the required number is 8. So the only shortage is 1. So now, this one can choose to lose these electrons, which are 7, to gain stability to remain with a stable shell, which are 2, or gain 1 to add to this one to make it stable. It is very easy for chlorine to gain 1 electron than to lose 7. and therefore it is going to gain 1 electron, which means the number of electrons this time around has 10 to 18, then 0. So let us do some mathematics. This one you're going to find it that 17 minus 18 is the answer is -1. Now we are not going to write a negative in terms of charge. We are just going to write a negative, not -1, but just a negative. And therefore Chlorine ion, that is the reason why it is written like this with a negative. Okay, so that is very important. Now for a formation of Chlorine ion, where can I put it? So let me just put it here. Formation of Chlorine ion, how is it going to be? So we are going to put up the structures like we've done for formation of positive ion. So chlorine configuration is 2. Let me start with chlorine normal, 8, 7. Then chlorine ion, the configuration is 2, 8, 8. So to start with, chlorine like this, how many shells? 3. Okay, 3 shells. Then around each shell, let me put electrons. So 2, 8 in the second one, then 7 in the last one. So 7 in the last one. Okay, so I'll put 1 here. Then this time around you are gaining electrons. So electrons, you add them this side. So 1 electron gain. Then it results into chlorine. The number of shells maintains. So you're going to have same number of shells. So this is the nucleus. This is the first shell. This is second shell. And this is the third shell. And please, if you are using electrons, you are using crosses, don't change to put dots here. Be consistent. So close, 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 close. So in the second shell there are 8. Then also in the third shell we have 8. Okay, this is chlorine ion. Then you put it in brackets. Those brackets, make sure that it's large enough. Then a negative just at the right upper corner, a negative. So this is how it is going to appear. So chlorine 2, 8, 7, chlorine ion 2, 8, 8. So this is how the ion is going to appear. I guess we have no problem up to this point. Okay. All right, let me give one more example, and this time around let us go for oxygen. So let us go for oxygen. So oxygen O has the mass number 16 and atomic number 8. The configuration is 2, 6. So it has 2 shells. Now look at this. 2 shells in the outermost shell. The first one is stable, but the next one is not stable. And if we were to look at this one, the required number of electrons is 8. So which means we have a missing of 2. So oxygen can either lose 6 electrons to be stable or gain 2. It is very easy to gain 2 than to lose 6. Okay. So in this case, oxygen is going to gain 2 electrons. Before any reaction, oxygen is electrically neutral, which means the overall charge of proton and electron is equals to 0. Okay, so if we look at it, the protons are 8 minus electrons, which are negative. If we were to look at this, the overall is 0. But since it will gain 2, the electron increased by 2. So we're going to have 8 minus 10, which is equals to -2. But for charge, we write 2 negative. Okay, so oxygen ion is written as 2 negative. Okay, so the configuration is 2, 8. Then we are going to have the normal oxygen with how many shells? Just 2 shells plus 2 electrons, then result in 2. Then in the first shell we have 2 electrons, In the second one, we have 6. Here we have 2. Then here we have 8. 8. Okay, so the configuration of oxygen is going to be 2, 6. For oxygen ion is going to be 2, 8. So please, these changes are very important where exams are concerned. Okay, so try out for sulfur. Okay, try out for sulfur and also fluorine and sulfur. Try out for these. So check on the periodic table, their atomic number and all that, and try them out. Okay, and also for nitrogen. Okay, also for nitrogen. All right, let us move further. This time around, let us look at bonding. So what is bonding? What is bonding? So we've raised a foundation. So formation of ion is what is going to help us in terms of bonding. So it's very important that you understand that part. So now it's very important that now we forge ahead and look at bonding. So bonding is just a chemical combination of 2 or more atoms. Okay? It's just a chemical combination of 2 or more atoms. And the only, so we can end there in terms of definition. And now we can add to this. You need to know that only the outermost shell electrons take part in bonding. So bonding is a chemical combination of 2 or more atoms. But you need to know that only the outermost shell, so the outside shell or the unstable shell, is the one that take part in chemical bonding. That is very important to understand. So only the outermost shell take part, or outermost shell electrons take part in bonding. Now the question that we should answer is that why do atoms form bonds? Why do they form bonds? So the simple answer to that one is that they form bonds to gain stability. It is all for stability. They want to be stable. So they can either choose to transfer electrons to other atoms or share. And this brings us to the type of bonding. So atoms form bonds to gain stability or to acquire the stable state. The types of bonds that we are going to discuss here, we have ionic bonding, we have covalent bonding, we have metallic bonding. So basically these three. But under covalent bonding, we have also what we call dative bonding. You might want to look at it. I'll give you an example where dative bonding forms, that is ammonia or ammonium. So this one, take interest and look at it. Dative bonding is just a kind of covalent bond. All right, let us start with the ionic bonding. So for ionic bonding, the simple definition or simple thing that you need to know about this one, that it involves the transfer of electrons from a metal to a non-metal. So one thing that you are going to find in the papers or questions is that maybe you might find a question, what type of bond is formed between metals and non-metals? The bond that forms between non-metals and metals is called ionic bonding. And this is done, or this occurs when metals transfers. Okay, so from where we are coming from on formation of ions, I think I did mention that metals normally lose electrons. And where do those electrons that metals lose go? So they are gained by non-metals. And of course, the forces between them is what we call ionic bonding. We are going to look at that in detail. All right, let us look at an example. So I've given here the example of an ionic compound. Okay, and we are going to look at how it is formed. So ionic compound, we have sodium chloride, magnesium oxide, and calcium chloride. How do these form? Because what we have here, in sodium chloride, we have sodium and chlorine. Sodium is a metal, chlorine is a non-metal. So now, how do ionic bond form? That is the question we are answering. So now, from where we are coming from, we know the formation of ion. And sodium, in terms of ion, it is like this. So, sodium, ion, I'm just presenting the structure, how it forms, how the ion appears. So it appears like this. How many shells? 2 shells. Okay, remember where we are coming from. Let me put electrons, outermost electrons, let me put 8. Okay, I'm just drawing the part for the final ion, not how it was formed. So this is what we learned, where we are coming from, that this is sodium ion. Then now there's also chlorine ion. We know how chlorine ion forms, so I'll put chlorine here. Okay, chlorine ion. And of course this one has how many? Chlorine is 17, 2, 8, 8. It becomes like that. So another, so this one has 3 shells. Confirm. So I'll put electrons. Now, since we are dealing with different elements, sodium and chlorine, I'll put dots, or you should put different symbol to represent electrons. So I'll put dots. Okay, I'll put dots to represent electrons in chlorine. Okay, now listen very carefully. We are saying this is the bonding that form due to transfer of electrons from metals. This is the metal and this is the non-metal. So when a metal, sodium, loses electron, if it is forming, in this case, sodium chloride, 1 electron that it loses, it is gained by chlorine. And therefore, we are going to show this arrow, this symbol, that this one was gained from here. And we put chlorine like that, put it like that. To show that this is ionic bonding, we put even this. So this is what we call an ionic bond. Okay, ionic bond. So the electron that is lost by sodium is gained by, this is positive please, is gained by chlorine. Okay, which is this electron that we are able to see here, this one. Okay, this electron here, okay, is the same as this, so it was gained by chlorine. And as such, sodium and chlorine attract each other. They form what we call ionic bond. So ionic bond is just the electrostatic force of attraction between the positively charged and the negative. And that is how ion or ionic bond form. Okay, you might want also to know how the transfer of electrons and all that occurs. Okay, I should have explained that, but since we've looked at formation of ions, I'll get to explain maybe in the next one. But for this one, let us look at it this way. I guess there's no problem up to this particular point. Okay, now let us look at the second one, which is magnesium oxide. So magnesium oxide, like this. So from magnesium oxide, you can see there's magnesium and oxygen. Magnesium is a metal, then oxide, or which is oxygen, is a non-metal. So now, let us put it this way. Let us show how the process forms. I know from this one, I've just given the final answer, but let me show you how it forms. Okay? Let me show you how it forms. So now, in this case, let me put magnesium here. Okay, magnesium here, like this. And magnesium, the configuration please, magnesium is Mg2412. The configuration is 2, 8, 2. Then oxygen, the configuration is 2, 6. So which means magnesium has how many electrons in the outermost shell? Has 2 electrons in the outermost shell. Okay, so in the outside shell it has 2 electrons. Then this side, let me put oxygen. Okay, oxygen has only 2 shells. So let me use different, so for this one I'll use cross to represent electrons. I want to show you how the whole thing forms. Okay, then we have 2 electrons on the outside shell right here. Okay, here we have missing electrons. Do we have missing electrons? Why did I put in the, I wasn't supposed to put electrons, something like this. Okay, so outside shell. So eyes on the outside shell. So for this one, I'll use dots. So inside we have 2 electrons. On the outside, we are supposed to have 6 electrons. So here, 2 electrons. So 1 is going to go there. Again, another one, because this one is going to lose 2 electrons. So 2 electrons are lost and gained by oxygen. So you show the arrows like that. Then here you can write before electron transfer. Okay, before electron transfer. Then here you can say after, before electron gain. Before electron gain. Then now we are going to draw the structures that shows after now. So the one for magnesium, after it has lost electron, it is going to lose a shell. This is magnesium positive. It is going to lose a shell, so therefore it will remain only with the 2 shells. So after electron gain, after electron loss, then this side oxygen is going to maintain the 2 shells, but just that it has gained 2 electrons. Look at this. These are being transferred here. So they've been gained. Now how is it going to become? So this one, you put them in brackets like this. This one, it loses 2 electrons, so it becomes +2. This one is going to gain the 2, so it becomes negative. So inside I can just put the electrons. I'll use close for this one. For this first one, I'll use close. Then here I'll use dots. Okay, dots for the electrons of original electrons of oxygen. Then for the one that it has gained, since they are coming from here and they are closest here, I'm going to put close here, meaning that 2 electrons have been gained from here. Then in the middle, I can put these lines showing ionic bond. So this is after electron transfer. This is after electron gain. So this is how the ions are going to become. This is magnesium, positive ion 2, 8. This is oxygen, negative ion, which is 2, 8. So this is how it is going to be. So this is how the process of ion formation or ionic bond formation occur. Okay, so try out for the other one that we've left out, which is calcium chloride. Or let me just explain on calcium chloride because I think it's a bit complex. So let me just explain also on calcium chloride to avoid confusion. It's a bit unique because it involves chlorine, 2 chlorine, and also 1 calcium. Okay, so what we have here is calcium chloride written as this. So the next part, please, is on writing chemical formulas. You should be able to know why it is written like this. So what this means is that calcium is bonded to how many? 2 chlorine, 1 calcium. So let us start with calcium. Calcium has 20 atomic number. This is 17. The configuration is 2, 8, 8, 2. This one, the configuration is 2, 8, 7. So now, what happened? So let me put calcium here. Calcium Ca has how many shells? 4 shells. So let me put 4 shells around calcium. Okay, so we have 4 shells around calcium. So don't mind my diagrams. Then we have chlorine. How many shells? 3 of them around. Remember, the first one is the nucleus. So 3 shells. Okay, and let me use so the first shell for this one, I'll put 2 electrons. Then the second one, there are how many? So 8 electrons. 8 electrons. Okay, then the outside it has 2. So I can put 2, or I can just, well, the shell is gone. So let me just redraw the shell. And let me just put the 2 electrons right here. Okay, then for this one, I will use dots. So for the first one, it has 2. The second one, it has 8. It has 8. Okay, the third one, it has only 7. You see? So it has only 7. So which means this one can only receive 1 electron to make it 7, to make it 8. So therefore, I need to draw another Crolene, okay, so that all the electrons, 2 electrons that are lost from calcium are used by Crolene. That is the reason why calcium chloride has 2 Crolene bonded to 1 calcium. So I'm going to put up another Crolene here. Since we are dealing with Crolene, I'll maintain the dash or the dots for electrons. Okay, it shouldn't be here. We're supposed just to have just 2 electrons. Okay, let me just put them nicely. So here we have 8 electrons. Okay, so here we have 7. We have 7. So one of the electron was going to come to this. You see? So 2 Crolene each need to gain 1 electron, but calcium is losing 2, so we need 2 Crolene. So please, if you find that the one that is gaining only need 1 electron, do not force now you put all these on 1. No, because you are going to defy the number of electrons that are needed. So you need to look at another element of the same that can gain an electron. So in this case, Crolene. Okay, so that is the before an electron gain. Okay, so this is before. Now after, how is it going to look like? After now, electrons have been gained. Okay, so calcium, it is going to be like this. So you can put calcium like this. So how many shells of calcium? You are just going to remain with 3 shells of calcium. Yes, you remain with 3 shells. You only remain with the 3 stable shells. Then for Crolene, so this one I can put it in these in advance and put positive. Then for Crolene, I can put Crolene here. How many shells of Crolene? Each is going to have, is it 3 shells? 1, 2, 3. So each is going to have 3 shells, yes. So each is going to have 3 shells. So I'll put for Crolene here, another Crolene here, 1, 2, 3. So these you can put like this. Put like this. I should have aligned them nicely, but I guess you're going to get the point, like this. Then in the middle here, you can put something like this. Okay, then you can put electrons inside. So this one, the outermost shell has 8. The outermost shell has 8. Also here 8, 8, 8, 8. Then here just 1. Then here 8. Oh, I shouldn't use this. You should use the different one. Okay, something like this, something like this. But remember, one was gained from here, so the inside part will just be of the same dots, dots. So please, it's common I might make a mistake when doing this. Make sure that as you go through, you confirm I'm dealing, or I've given correct diagrams. Okay, so it's going to be like this. This one, please, I've used the one that has been gained. So that is how it will look. That is calcium chloride. I hope you've picked something here. Okay, let us look at now the characteristics of ionic compounds. What are the characteristics of ionic compounds? So one of the characteristics of ionic compound is that they have high melting and boiling points. So one of the characteristics is that they have high melting and boiling points. And these are the questions that you might find. So state characteristics, or some of these are characteristics of ionic compound. So one of them, they have high melting and boiling point. And maybe the question is that why do they have, this time around it comes, why do they have high melting and boiling point? And the answer is because of the strong electrostatic forces of attraction between the ions. Because of the strong electrostatic force of attraction between the ions. Then they are soluble in water, but insoluble in organic solvents such as ethanol, petrol, or oil. So they are not soluble in organic solvent. They are soluble in water, but insoluble in organic solvents such as ethanol, petrol. They conduct electricity in aqueous or molten state because of the ions that are free to move. So they conduct electricity in aqueous or molten state because of the ions that are free to move. Then they are non-volatile and generally solid at room temperature and pressure. So very important to understand this. They are made up of ions of positive and negative ions. So very important. And of course, in addition to that, make sure that as you study, make sure that you look at uses of ionic compound. I'll give you an example of sodium chloride. Sodium chloride is a typical salt that we use and normally use for flavoring. So we put salt in a relish or whatever food for flavoring. So one of the uses is add flavor to the food. So get to look at some more uses of these compound. Very important. All right, let us shift our attention now to covalent bonding. So covalent bonding, what does it involve? So covalent bonding involves sharing of electrons. So in ionic bonding, we said it involves transfer of electrons, but covalent bond involves sharing of electrons between non-metals. Okay, so that is very important, and it results into the formation of the molecule. Okay, so a molecule is just the simplest particle of an element or a compound. That is how we define a molecule. What are some of the examples of compounds, or what are some of the molecules that are formed by covalent bonding? We have hydrogen, carbon dioxide, ammonia. Okay, so now how are they formed? So look at this, sharing of electrons. If you look at hydrogen, it is hydrogen atom and hydrogen atom. Now here we are dealing with the ordinary hydrogen, which is hydrogen 1, which has atomic number of 1. So if you were to draw the structure for hydrogen 1, which is H, it only has 1 electron in the first shell. So hydrogen only has 1 electron in the first shell, and it is not stable because the first shell, the required number is 2. So hydrogen here, for it to be stable, it will tend to share with another hydrogen, because another hydrogen here also has 1 electron. So they say, okay guys, let us come together and share, and so that we can be stable. Remember, bonding is all about making atoms stable. So atoms of hydrogen, they will share what they have. This one has 1, this one has 1. When they put them together, it makes 2, and that is stable. So how do they share? So they come together like this. So in this one, you just put up the outside shell or outermost shell. Another hydrogen here. These electrons that they have, they come in between here. So if we were to count number of electrons in the first hydrogen, 1, 2. The second one, 1, 2, and they are stable. And this is the covalent bond between hydrogen atoms, okay, resulting into hydrogen. Okay, so that is how this is how covalent bond is formed, by sharing of electrons. Okay, let us look at carbon dioxide. Carbon dioxide is carbon and 2 oxygens. So 2 oxygen and carbon. Normally when it is written like this, this one is the one that becomes at the center. So in other words, we have carbon in the middle, oxygen this side, and oxygen the other side. Now oxygen does not form a single bond. Instead you have double bonds. So this is how carbon dioxide looks like. But in terms of the structure, how can we put carbon dioxide? So carbon itself, carbon has only, since we are showing just the outside shell of carbon has 4 electrons. Okay? Then if we were to draw the oxygen this side, the structure for oxygen has how many electrons in the outside shell? It has 6. So oxygen has 6 electrons. So let us put them 6. Okay, let me put 6. Then also the other oxygen, okay, also has how many? 6. So how many does oxygen need for it to be stable? It needs 2. How many does other oxygen need? It needs 2. How many does carbon need? Carbon need 4. So this one is going to contribute to, making carbon stable. At the same time, this one is going to share 2, and also this one is going to share 2. Okay, making these stable. Okay, I guess you get the thing. So it is going to be like this. It is going to be, let me just try to draw a bit big diagrams. So it's going to be like this. Okay, so here what we are going to have, this is the oxygen, this is oxygen, this is carbon. So carbon is going to share 2, and also even this side is going to share 2. Oxygen is going to share 2, also this side is going to share 2. But remember, oxygen remain with 4 on this other side. Then also this one remains with 4. So if we were to count the number of electrons on oxygen, you count also the ones that they are sharing, which are 4 here. So 4 plus 4, 8. Also the other side, 4 plus 4, 8. So oxygen and oxygen are stable. But carbon in the middle, also you count these and these. So 4 plus 4, 8. And that is how carbon dioxide form. But since this is contributing one, also this one, so this is one bond. We draw a line. This one is contributing, and also this one, this is another bond. We draw a line. So this is what we call the double bond. Sometimes this one can contribute another one, and this one another one. They make 3. This is what we call triple bond. So you should be able to know these things. All right. So you have a look at ammonium. Like I said, there's also another type of covalent bond which is called dative. So dative bond, look at ammonium as an example, and of course be able to provide your answer. Let us look at characteristics of covalent bonds. So characteristics of covalent bond, we can look at they have low melting and boiling points. So it's just the opposite of ionic bond. So they have low melting and boiling points because of the weak forces of attraction which holds the molecule. They are soluble in water. They are soluble in organic solvent, but insoluble in water. They do not conduct electricity. In addition to that, they are volatile. They easily escape. So this is very important. But as you go on with the studies, you are going to realize that covalent bond could be one of the strongest bond that ever exist because of equal sharing of electrons, but that is another thing for another day. Let us end by looking at metallic bonding, which is just the shortest. So metallic bonding, what is it? Even if this is the shortest part, but it does come in an exam. So metallic bond, very important to know that, is attraction between positively charged ions of metals, positively charged ions, and the delocalized electrons within a metallic lattice. So it is an attractive force of attraction, attractive force or force of attraction between positively charged metal ions and delocalized electrons in the metallic lattice. That is what we call metallic bonding. And in multiple choice question, these questions are always there. So it's very important that you understand that particular part. Now, in this case, let me just put up a drawing to add spice to what I've just said, or to this part. So let us say this is the ion, or this is sodium metal, because this one occurs within or inside a metal. So when you see a metal, just know that there's metallic bonding within. So let us look at the atoms of metal. Okay, sodium. Sodium, we know that loses one electron and becomes positively charged. So let us say that an atom of sodium loses an electron and becomes positively charged. These electrons start moving freely within the metal. Another atom loses, become positive. The electrons start moving freely. Another atom loses, become positively, and an electron start moving freely. So electrons I'm denoting, so key electrons, or I can put something like this, okay, to represent electrons. Then positive charge represent metal ion. So this is what happened within a metal. So it loses electrons, and the electrons, they are freely moving within a metal lattice. Okay, now these positive and negatively charged electrons, they start attracting each other, and that is what we call metallic bonding. So the positively charged ion and the negatively charged electrons start attracting each other within a metal, and that is the reason, that is what we call metallic bonding. Perhaps the other question that you might find is that, why is a metal a good conductor of electricity? And this is because of a delocalized electrons, or electrons that are freely moving. They carry charge, okay, resulting into the flow of current. As a result, electricity is able to flow through, or heat. Okay, that is another thing for another day. Otherwise, that is metallic bonding. Okay, so I guess you've enjoyed the lesson from the start. It has been quite some time from the time we started, but I guess you've not lost touch. All right, at this particular point, if you've understood, please, if you've enjoyed the lesson, do not forget to subscribe to this YouTube channel, as we have more content, interesting content coming. But if you are writing exams next year, be it GCE or school certificate, IGCSE or GCSE, that is Cambridge, you are free to join us for online lessons. To start with, you can contact the number 0976 402563. But if you stay within Lusaka, we are found in Kawata area, just near Kawata Primary School. If you are interested, or if you stay in the same locality, you can still get in touch, and of course we can give you directions. Otherwise, thank you very much for staying up to this point, and see you in the next one.